Hi, so today we're going to calculate the square root of complex numbers written in the general form. Remember that the general form of a complex number, also called the rectangular form, is z equals a plus bi, where a is the real part and b is the imaginary part. Okay, so in general terms, the square root of a complex number is a complex number. Remember that above the real numbers, we've got the complex numbers, so complex numbers englobe more than the real number. So we have to suppose that the square root of a complex number is a complex number. So if we want to find the square root of a complex number in the general form, what do we do? So we're going to look at an example. Imagine that we've got z equals 3 plus 4i, and we want to find the square root of this number. We're going to call that square root x, and we are supposing that x is written in the form a plus bi. Okay, so what are we going to do? Well, we're going to square that whole equation. Okay, so we're going to elevate it to the power of 2, and by doing that, the square root goes on the left, and we have that 3 plus 4i equals x squared. But x squared is a plus bi, so it can be written like this, and we can multiply that. And we have, that's a perfect square, so we have that a plus bi squared is equals a squared plus 2abi plus bi squared, but I squared is minus 1, so we have minus b squared. Okay, so in general terms, we have that 3 plus 4i equals a squared plus 2abi minus b squared. Okay, so what do we do with this equation? We have to remember that two square numbers are the same if the real part and the imaginary part are the same. So we are going to generate two equations where we say that a squared minus b squared, which is the real part of the right side, equals 3, which is the real part of the left side, and 2ab equals 4, which is the imaginary part of both complex numbers. So we can say that here, if we leave b as the subject of the equation, the b equals 2 divided by a. And if we substitute this on the first equation, we have a squared minus 2 divided by a squared equals 3. And if we operate that a bit, if we do some mathematics there, we have that a squared minus 4 divided by a squared equals 3. Multiply everything by a squared, and we have a to the power of 4 minus 4 equals 3a squared. And if we arrange that a bit, we have a to the power of 4 minus 3a squared minus 4 equals 0. So we have an equation to the power of 4. We know how to solve those things. We're going to substitute, do the following substitution. We're going to call t equals a squared. So if we say that t equals a squared, that previous equation, which was a to the power of 4, so that's t squared, minus 3a squared, so minus 3t minus 4 equals 0. Okay, this is a quadratic, this is easy, so t equals 3 plus minus the square root of 9 minus 4 multiplied by minus 4 divided by 2. 9 plus 16 is 25, the square root of 25 is 5. So we have this, and this gives us two solutions, 8 divided by 2, which is 4, and minus 2 divided by 2, which is minus 1. Okay, so t equals that. If t equals that, we have two options. a1 squared equals 4, so a1 would be plus minus 2, the square root of 4. A2 would be minus 1, so that's the square root of minus a2 squared, so the square root of minus 1 would be plus minus I. But we're going to consider this as an absurd solution, because we said that a was the real part, and we can't have a real part with an imaginary number. So we're going to say that this solution, we can going to discard this solution, and we have then two options. We have the option that a equals plus 2, so b equals 2 divided by 2 equals 1. So our first solution is going to be 2 plus I. If we consider that a equals minus 2, then b equals minus 2 divided by 2 equals minus 1. So we have our second solution, which is minus 2 minus I. Okay? So we have here the solution of our square root. We could also write this, consider that this is if we extract the minus. So we could say that the solution, then general solution, would be plus minus 2 plus I. Okay? So it's the same, and it's really straightforward.